Good afternoon, everybody. Thank you so much for joining us today. We're going to have a webinar on Bimba IntelliSense, and Jeremy from Bimba and Doug Grog from Hydropower will be presenting. So if you have any questions, please put them in the chat, and we'll make sure to go over those. And I'm going to hand it over to Jeremy.
Thank you very much, Sarah, and thank you everybody for joining us today. My name is Jeremy King. I'm the product manager at Bimba for Sensing and Vacuum Technologies. And today's presentation is going to give you a brief overview of the IntelliSense platform and some of the capabilities that it brings to your pneumatic circuit. So IntelliSense is a product that Bimba developed about 6 years ago now, and it was designed to address some of the key issues that were affecting us and our customers around manufacturing efficiencies, trying to reduce our downtime within our facility, simplify our maintenance routines, enhance our machine efficiency, improve our product quality, and provide remote monitoring for our operations staff, which in light of the current situation is even more critical than it was when we first developed the product. So those are kind of some of the things that were driving the development of this product. What is IntelliSense? That's probably a good question to answer. It's a unique combination of hardware and software that provides real-time insights into the condition of your pneumatic components. So we like to call it predictive prognostics, where we're able to look at changes in the performance of individual components within your pneumatic circuit and predict how much longer they're going to last in your current application based on your current parameters, primarily around pneumatic actuators, which is what everybody knows Bimba for, and where we have put most of our R&D efforts. However, we have expanded the capabilities of the IntelliSense product to touch on other aspects of the pneumatic circuit, and we'll talk about those today as well. We also provide that remote monitoring capability that I talked about, machine efficiency inputs. So if you're doing OEE calculations, sometimes it's difficult to get some of the inputs for those calculations. IntelliSense helps with that. And there are ways we can use IntelliSense to improve the quality. So most of today's presentation is going to be me going through a live demo of the remote connectivity capabilities of IntelliSense and some of the functionality that that provides us. Then after I do that, I will hand it off to Doug Grog briefly, who will show how we can use our physical demo unit to simulate some of the failure modes in a pneumatic actuator and how IntelliSense will respond to those changes in performance. And then after that, to wrap up, I'll go over some success stories we've had with IntelliSense and discuss applications where IntelliSense has been able to provide benefit to our end customers. Hopefully you guys see some similarities in your operations where you might be able to do the same thing. So we talk about IntelliSense, we talk about providing insights into what you need and where you need them. Now, most customers have sensors somewhere in their facility, maybe lots of sensors within their facilities that are collecting data all the time. Now, a lot of times that data is then collected and put into a data warehouse and stored, never to be seen again. Because in reality, a lot of it is just a lot of numbers, and you don't know necessarily what to do with it, what it means. What should I do when I see those numbers change? So what we wanted to do with IntelliSense is take our 60 plus, almost 65 years of pneumatic actuator experience we had at Bimba and tie that into the data being collected from the software and provide you guys insights into what we're doing. So depending on where you're at in an organization, though, you need different insights. If you're on the maintenance team, you know, you're worried about making sure the machines are up and running as much as possible, avoiding unforeseen downtime, improving the scheduling of your maintenance cycles, reducing the amount of time it takes to repair machines. So you're looking for one set of data. If you're on the quality team, you know, you might be looking for force data. How much force is my actuator generating during my clamping application or my heat seal application to make sure I'm making a good quality product every time, and tying that back to cycle count data. Or if you're in the operation side, you're looking at machine efficiency. You're looking at throughput capabilities. You know, how many products did I produce today based on how many times the cylinder actuated? All of those are the types of insights we're trying to provide through a simple user interface. And that was one of the main drivers behind IntelliSense, was taking stuff that was already available and making it easier to get, simpler to understand, and make it something that people are actually going to use on a regular basis and not just collect data that no one's ever going to look at again. Now, if you're a machine builder, you're looking at this from a slightly different perspective. You know, you're looking at, how do I use this to improve the machines I'm already designing? You know, if you're a controls engineer, you can use the data coming off of IntelliSense, pull it into your PLC via Modbus, and actually make performance changes to the way the machine operates based on real-time condition within the system. Now, because the way that really affects you is, we all assume a pneumatic actuator is going to extend and retract the same way every time. But in reality, because there is a rubber seal on the piston and on the rod guide, the performance of an actuator changes over time. It initially speeds up as the seals begin to wear and break in, and then once they've worn past a certain point of usage, they then begin to start leaking and the cylinder slows down. So if you're doing a very tightly sequenced operation and everything needs to happen at a set amount of time, changes in cylinder performance may affect the performance of your equipment, and the quality of the product being produced over time will change. So that's another thing to look at if you're doing that. The other part of where IntelliSense can be a great help on the OEM side is in prototype validation. So you've built your first machine. You want to make sure that everything's running right. You can use IntelliSense as a way to help diagnose the different components within your pneumatic circuit to make sure they're doing what you expect them to do. So let's take a look at some of that here. So how do we get these insights out of this IntelliSense system? Well, the heart or the brains of IntelliSense is what we call our sensor interface module. This device is about the size of a deck of cards and contains 2 sensor inputs and quite a few different outputs. The primary one, if you're in the plant, is a red, yellow, green status light right on the front, telling you the condition or the health of the device you're monitoring. We also have 2 other status lights on there that will tell you cylinder position, or depending on if you're connected to other things, whether or not different things are in spec. Now, beyond that quick visual, there are multiple ways to get at more detailed information. We have 2 syncing outputs available that are user configurable, so that you can tie this into a stack light or some other operational control, so that you can get a quick notification of a change in performance. We have a serial PC connection that you're able to connect a laptop directly to the IntelliSense SIM and get real-time performance data on what's happening with that particular device that's being monitored. Or, as I mentioned before, you have the ability to connect Modbus to it and pull 45 different registries for all kinds of detailed information about your pneumatic circuit. So let's talk a little bit more about the 3 operating modes that we have available with IntelliSense. Again, the most developed one is our cylinder monitoring mode. This is where you get the predictive algorithm around how much life is left in the cylinder. You've got 24-hour, 7-day-a-week monitoring of the condition of that device. So you're going to get warnings ahead of time before anything goes wrong on a critical application. We have just released recently our vacuum mode. Now, the vacuum mode is an upgrade. It was a free software upgrade that we've made available, or we will soon, that allows you to monitor Venturi vacuum generators. So if you use a Venturi vacuum and you have issues where you start dropping parts because of cup wear or other issues because the vacuum level begins to leak over time, We've got a solution that will allow us to detect those changes in vacuum performance and give you a notification that there's an error in your vacuum circuit. And then the third mode of IntelliSense is pressure temperature monitoring. Now, this is basically a smart pressure switch that's highly configurable. You get two pressure switches, each of which you can set an upper and lower warning and an upper and lower alert. So it's a two-stage pressure switch that allows you to get signals as to changes in the performance. And we've been using this mode kind of as a bare bones data acquisition, pressure data acquisition tool in quite a few applications. But in the pneumatic circuit, we've been using it to monitor the FRL to make sure that you're getting sufficient airflow through the FRL to supply your actuators the way you would expect them to be supplied, that you're getting enough air pressure, and to monitor plant pressure to make sure the plant pressure to the FRL is sufficient. We're also using it to monitor valves to see if there's any leaking across the valve seals within a circuit. Again, monitoring the supply pressure and then the valve, the switched pressure to see what's going on. And we'll show you all that in real time. So that's a lot of talking about a theoretical thing that you've never seen, never heard of. So what I'm going to do now is actually switch over to IntelliData.com, which is a website that we have set up that allows you to, all right, somehow I just turned on subtitles, which is interesting. Anyways, let me escape out of here and start my web browser and go to IntelliData.com. This is a real, like I said, this is a real demonstration that's set up in our facility in University Park, Illinois. All right, so when I first log on to IntelliData.com, I see 5 different devices attached. Now, if you were to use IntelliSense in your own facility, it is separate from IntelliData. IntelliData is just our demonstration site. Any data collected by IntelliSense, any of the analytics, any of that is stored locally on your site. Nothing goes to the cloud. Nothing gets outside your building unless you want it to get outside your building. So if you're worried about security, it is very easy to tightly control the information coming in and out of IntelliSense. So just wanted to put that out there real quick before we got too far into this. So now with IntelliData, I can quickly come in here and see I've got my 5 devices. My vent actuator appears to have some sort of problem. Well, I can either click directly on my vent actuator or come up here to my alerts and it says actuator temperature out of range. Well, let's find out what that means to me. So if I click on my alert status, I get to the main status screen for IntelliSense. Now this is the cylinder status screen, and it's telling me that this particular actuator has been in service for a little over 11 million cycles since 2014, averaging 17,843 cycles a day, and that I've got a little over 2 years left based on its current performance until it sees a failure. So, you know, everything seems to be going all right, but I've got this temperature alert at 74 degrees Fahrenheit. Well, the temperature that this is reading is a combination of the air temperature in the pneumatic circuit and the ambient ambient temperature. And this vent actuator is actually a mock-up of a real customer application where they had cylinders mounted to a vent in the roof of their facility, and they wanted to be able to automatically control when that vent would open or when that vent would close based on the ambient temperature, because they found that if it got too hot up there, something in their process would be off and that they would have problems. So we used the built-in temperature sensor in IntelliSense to provide them that data so that they can take an action based on the increased temperature near this cylinder. And I also actually permanently set this alert, so I have something to talk about when I demonstrate the software. But that being said, I can see my extend and retract times are coming in at about 1/10 of a second, which is within my specification of 1/2 a second. My line pressure is probably a little low. I'm running the cylinder at 38 PSI, but it's again within the limits that I've set on this. So all of that looks good to me. So I don't have any big concerns there on my performance. I do see down here that I've got a bit of an air leak in my rear piston seal. So, you know, my cylinder has begun to wear a little bit, and I am starting to see some issues with leakage. Now, in this particular application, air leakage isn't a big deal. It's not that expensive for it to leak a little bit, and my cylinder is still operating within the amount of time that I was expecting. So I'm not worried about that. I'm going to keep going, but you know, let's dig in. Let's see, what does this really look like? And I can switch over to monitoring mode and get real-time data from this actuator and see what's going on inside the air cylinder. This is the 2 pressure readings. Let me actually hit play and turn on temperature as well. Get the next cycle, I'll pause it here so we can talk a little bit about what we're seeing. So this here is the real-time data coming into the sensor interface module. The yellow line is my extend stroke, and I've got normal pressure. My valve has switched. Pressure builds in my cylinder. It breaks away. Pressure decreases as the cylinder moves because the volume is expanding. I get to the end of travel, and then I begin to build pressure up in my cylinder. Now, a couple of things I can notice real quick looking at this is I've definitely got some leaks within my cylinder. Because I've got this nice upward slope on both the extend stroke and the retract stroke, it's most likely a piston seal that is leaking. Because if it's a brand new cylinder, that actually goes up and that line is perfectly flat because I've fully pressurized the cylinder and the air is just not going anywhere. But because there's a leak, there's a bit of an upward slope. Again, not a big deal for this application, but it's something to keep an eye on. Then I get over here and my valve switches again and I begin to retract. I dump my air. I actually build up a little bit of back pressure at the end of my stroke. So that's where that's slowing me down a little bit as I'm trying to force all that air out of the cylinder. And then I get a little bit of chatter because the cylinder will bounce at the end of the extender retract stroke. This particular cylinder is actually unloaded, so that's where some of that chatter comes from. The other thing you can notice is that my temperature is pretty steady on either side of here, but there is an increase when the cylinder extends and a decrease as well. And that's just the hot air from the cylinder being expelled through the exhaust port, causing a bit of a temperature rise, and the cool air coming in from the plant cooling it down. Now, a lot of information available on this screen, but let's say you wanted to dig in even deeper. We do have the ability to export the raw data being collected by the SIM, where we can do sensor pressure, temperature, line pressure, ambient pressure, performance cycle. The cycle count data is what I really like to use. I tend to use cycle count data in conjunction with extend retract time or the sensor pressure to plot out what's going on with my machine. How well is it performing? I can download that data to an Excel file and get deeper insights. I also can, any of my alerts, my temperature alerts, my pressure alerts, my seal failures, I can get whether or not those are active. This particular one is set up where I can get any data from the last 2 or 3 days, 5 days, and export that. Now that is a manual process. It is not set up to automatically download. If I go over to my configure screen real quick, this is the configuration settings that are stored on my SIM. I've got the name and where it's located, my part number if I had it, all kinds of diagnostics tools. But what I want to show you real quick are these alert detection thresholds. This is where I define what I consider a failure in my system. When do I want to be notified of a change in performance? So in this case, I'm saying my extend retract time of 500 seconds is fine, or 500 milliseconds is fine. That if it leaks more than 5% of the air being supplied to it, that starts to get a little expensive, and I might want to address that. That if my line pressure is too low or too high, so is my operator adjusting the line pressure on third shift to try to get a little bit more out of the machine, which, you know, may speed up the machine, but also causes increased wear and tear and will cause cylinders to wear faster and other components to wear faster. So, you know, machines are designed to run at a specific pressure, and if somebody starts messing with that, you can have unintended consequences. So you want to monitor that. Then down here in event detection, I set how often do I want it to tell me that some significant change has happened. And in this case, I've got it set that if the extend or retract time changes by more than 20 milliseconds, that is a significant change in performance to me. I want it to make a prediction as to how many more cycles it's going to get until it reaches that 500 millisecond limit. So we're just chugging along pretty good right there. Last thing to show you here is the two outputs. So I can set line pressure, seal condition, temperature, extend times, retract times, all of those to set off those two syncing outputs. So that's my cylinder mode. But look, I've got a new one, a vacuum pick and place low vacuum warning. Let's jump over there and see what that is telling me here. Well, sensor one is telling me that I've got a vacuum alert. Oh, it went away. That's because I've actually got this set up to simulate a wear on a vacuum cup, but that's all right. This particular vacuum system has been in service for, again, 7 million cycles, 14,000 cycles a day. So just chugging along since middle of last year when we started testing this. And what's this telling me is that during the working portion of my vacuum cycle, my vacuum level is within the specification I'm expecting, and that my supply pressure to the actuator is within the pressure that I'm expecting. So we're only monitoring supply pressure and vacuum pressure during the working portion of the cycle. And why is that important? Because if I were to use just a regular vacuum sensor on here, or a vacuum switch, every time I turn the vacuum on or off, I would have to account for the switch firing. And I don't necessarily know, is it firing because I turned the vacuum off, or is it firing because I dropped a part? So we're able to monitor that, looking at our real-time pressure data one more time. Here we go, pause. So this is actually the cycle that has a leak on it. My valve switches, I provide pressure to my venturi. I've got steady line pressure here. I've got a bit of a build up to my pressure here, and then I drop down a little bit as I get a little more vacuum. But this is outside of my limits. So I get an alert every 4th cycle. And that's because I've got a valve that actually opens up every 4th cycle to cause a minor leak. But if I were a automotive windshield manufacturer and I'm trying to move large, heavy windshields through my facility using vacuum cups, and those cups start to wear out and I start dropping windshields, well, those windshields are a couple $100 each. It's a very expensive damage because I forgot to change out a $20 cup. IntelliSense can help tell you, hey, I'm starting to see leakage on my device. Now, the last thing I do want to show you here is our pressure temperature monitoring mode. And again, in this mode, we're monitoring the supply pressure and the regulated pressure on a FRL. Now, we are looking at a future edition to provide pressure drop and do you need to change the filter, but right now we're just monitoring that we've got sufficient supply pressure coming in and that our cylinder is seeing the air pressure we want. So in this case, turn on the monitoring mode one more time. my favorite diagnostics tool for pneumatics. You can see my plant pressure is just under 110 PSI absolute. There's some variation as different machines come on and off within the facility as different things are going on, but it's a pretty stable supply pressure. But if you look at my regulated pressure, now it's pretty clear that the regulator is set at probably about 88 PSI. But then every time the valve opens to actuate the cylinder that's attached to this, I see a pretty significant drop in pressure. Now, that's not a big deal in most situations, but it's something that you're not always aware of. And in this case, it's a single actuator. Everything's going to be working the way it's supposed to. But let's say that that cylinder was providing clamping force to an operation, and that the amount of force generated by that cylinder is critical to my application and to the quality of my product. If that varies too much, I'm going to see quite a bit of variation in my seal quality. So it's something to be aware of, something to keep an eye on. Because the other thing that comes into this is if I look at my yellow line here, like I said, that variation is due to different things in the plant coming on. If I've got multiple valves, multiple devices being fed by the same regulator, I could have a second valve open up right here when I'm already at 80 PSI, and I'll see another 5-6 PSI drop in supply pressure. So where I think I'm getting 80 PSI from my regulator, I might only be getting 50 or 60. So I'm going to see changes in the performance of my actuators. So it's a great diagnostics tool to help you see that. So let me go back. One last thing to show you guys here. In my configuration mode, I can connect up to 12 devices to a single IntelliSense data gateway. Each device, each SIM can monitor one pneumatic component within your circuit. I can assign as many users as I like. I have full control over my network settings as well as SSL encryption. So again, if your IT department is concerned about putting things on the network, it's a very easy to secure Unix-based web server. So not a big deal. We just drop ours behind our firewall and keeps people locked out. Now, the last thing you can also do is set up your email server so that every time an alert goes active, you will receive an email saying, hey, this alert is active. Now, it doesn't have any sort of escalation functionality or anything like that. It is just a basic one-time alert. But it is a way to get a quick notification that something is going on within your equipment that's not supposed to. So that's the quick rundown over IntelliSense. A couple other things: you can change between English and metric, as well as we do support multiple languages depending on where and how you're operating. So that is IntelliData. So I've spent a lot of time talking about what IntelliSense is, what it can do, but I haven't really talked about the hardware. And that's because with a product like this, you need the hardware. The hardware is the hardware. It does what it does. There's not a lot of flexibility there. It's what the software does. What do the insights you get out of the system do? But real quick, I'm going to show you a static picture of IntelliSense, walk through what the components are that are allowing us to do this. And then we're actually going to switch over to Doug Grog for a few minutes, and he's going to give you a live demonstration of the demo case, showing how he can create a leak and detect that leak using IntelliSense. So right here we have a standard pneumatic double-acting cylinder. IntelliSense is designed around double-acting cylinders, single rod. It can be used for a double rod or a rodless cylinder. Just the user face is not quite tuned perfectly for those operations, but we can work with you to make it work for those. So it's not exclusively that. It was originally designed and developed and tested using Bimba actuators. However, the fundamental physics of what I just showed you and how IntelliSense works will work with anybody's pneumatic actuators. So we've got a wide variety of customers or products we can support using this. So next to my pneumatic actuator, and same thing on the Venturi. We developed it using our own vacuum, Venturi vacuum products. However, the fundamental physics are the same, so it should work fine if you're using a competitor's product with that. So connected to the actuator are 2 pressure sensors. Now these pressure sensors are about the diameter of a nickel. So they're very small and they're very lightweight. They're a digital pressure sensor, and they come with a pre-attached fitting. So if you're going to install IntelliSense to monitor something, it's very quick and easy. Shut down the machine long enough to cut the air lines, put 2 quick disconnects on there, and run the cable, and you're all set. You can turn your machine back on, because if the whole point in the system is to avoid downtime, we don't want it to take 3 hours for you to get your machine back up and running once you've installed the sensors. Now, the sensors should be mounted as close to the device you're monitoring as possible, but we do mount them slightly off because in high force, high speed applications, we have found that the shock and vibration created by the cylinder can damage the sensor. So we use a little bit of airline to act as a shock absorber. The only other thing to keep in mind around where you put your sensors, they are all stainless steel, so they're good in wash down applications. We do have IP69K cables available. So again, not a problem if it's out in an environment. You do want to make sure that if you're using flow controls or quick exhaust valves, that they are mounted outside of the sensor. So the sensor needs to be able to see what's going on directly inside the cylinder, and a flow control may impact what it's seeing. So it is good to move those outside. Now, these 2 sensors collect both pressure and temperature. Pressure every millisecond, temperature every second, and provide that data to the SIM. The SIM is the key device here, and this is where all the data analytics happen. If you were to use the PC software that I mentioned, you would plug directly into the SIM and you would see everything you just saw with the Data Gateway IntelliData demonstration, except for you can only monitor 1 device at a time and you don't get the email alerts. And there's no data logging if you don't have a computer connected. So the Data Gateway works as the data logger. Your PC works as a data logger when you're connected. There is no internal memory here. But out the bottom of that, I've got my I/O ports, which will connect to, which we have set up on the demo case that Doug's going to show you, are connected to the 2 green lights that you see over to the right, which will indicate cylinder position. The PC connection in the middle is connected to the data gateway, providing remote connectivity and configurations. And then the Modbus connection is connected down to our PLC. And in this case, it just turns the light on and off on the PLC, but that's all right. And then finally, this is our data gateway. This is a small Linux PC running CentOS and a web server that provides all the connectivity and the control. The device between the SIM and the data gateway is our junction block. It's just a device that makes it a lot easier to wire all of that up. So that is the hardware and an overview of the software. Now we're going to switch over to Doug, who's going to give you a video demonstration of our demo case. Once Doug has finished showing that functionality, we're going to come back and I'm going to talk to you a little bit more about some real-world applications that we have for IntelliSense. So Doug, if you'd like to take over.
All right, welcome everyone. So for this, if you guys can look over to where videos might be available, if you guys can see my the video that I'm shooting, and on that you should be able to, there should be the 2 little arrows to expand it, or maybe double click on it to expand that so you can get a closer look. So what we're going to do here is like Jeremy had said, we're going to demonstrate how to show or reenact a leak here, and then we'll see it pop up. I've also got the IntelliSense program running on my laptop here. So you can see one thing I already did was just for kicks, I had lowered the temperature setting, and that was just internally. I just lowered it just so that we could see that those alarms are going to get triggered. But right now you can see it's saying, hey, we got a good rod seal, rear piston seal, and front piston seal. And so the first thing we're going to do is we're going to basically introduce a rod seal leak into the system. And so we've got fired up, and then so what we're going to do is we flip these both up like that, and all I'm going to do is just open up this flow control up top.
A pretty good leak you got there.
Yeah. And then I'm just going to turn it into this cycle mode. So right here we've got manual mode, and then retract, extend. This is just manually operating it. And these auto and cycle modes, you can go through the manual, but they're just different types of programs that have already been pre-programmed here. But what I'm going to do is I'm going to turn it into cycle mode, and then we're going to go over to the screen to see how we can see it change from a good seal to a bad seal. So it's in cycle mode, and then we can come over here and there you have the rod seal leak come on. And then, of course, your maintenance guy goes in, fixes the seal, and we're back in business. So the next one I'm going to do, I see something here. Oh, okay. Is everyone seeing the video all right? Jeremy?
Yeah, we can see it. We can see it.
Okay, yeah. Great. Okay, so the next one I'm going to demonstrate is the front piston seal. So actually this stays open. And we're just going to switch this down there.
Yeah. And if you notice the green light is blinking while he's doing that, that's because there is that temperature alert. So it's just another visual indicator. Hey, the cylinder is still good, but I've got some sort of alert going on.
So we just turned it over to the cycle mode. And there you have that. And so the last one is going to be that rear piston seal. And so all I'm doing here is just switching out where those leaks are. And then we'll turn on the cycle. And there you have it. And so other things to just kind of show you in general is that you can see those cycle times adjust. You can see as the temperatures are adjusting as well each cycle.
And your web interface updates once a second, just so that you understand why there's a bit of a delay.
I think that's it for at least demonstrating the leak. So I think with that, well, anything else to show, Jeremy?
No, like I said, it was good to see the flashing light there, letting you know that there is some sort of indication that you could go in and dig in for more information, and then two positional lights. so that those switching outputs that you saw there where the green lights were coming on, that is another way you can use IntelliSense that I forget to talk about quite a bit, and that you can use it to replace reed switches, because it will detect end of travel. Now, it's not going to be as positionally accurate as a reed switch, but it will tell you when it's finished traveling, extend, or retract, and you can use that as a input into your system, so that maybe you have inconsistent positioning. So you're not always pushing the same size box or something. You can use IntelliSense in place of reed switches. So great thing to remind me of. All right, so we've got a little over 20 minutes left, I think. Where's my clock?
2 questions so far.
Okay.
Is it possible to communicate through IO-Link? Is the first one.
No, Dan, not at this time. It is just Modbus. When we developed this 6 years ago, IO-Link wasn't really around, and we were looking for a communication protocol that was going to be as universally accepted as possible. IO-Link is something we're looking at, but it is not a current option.
And then the second question, any plans for Bimba to look into vibration IntelliSense as an option to temperature and pressure?
Not with the current generation of hardware, but we're looking at more and more sensing capabilities to add to this in the future, so I will put that on the list. All right.
If anyone has questions, feel free to put them in the chat or unmute and just.
Well, what I'm going to do now, Sarah, is let's switch over, and I'll spend the last 15 minutes and open it up for more questions at the end, and I'll run through some real-world applications. Show you guys some different ways we've used IntelliSense to help different customers around the country.
Great.
So the first one that I love to talk about is a palletizing application at a oil and gas facility down in Louisiana. They actually bottle motor oil for aviation and automotive application. And in this case, it was, it's kind of funny to me. It looked a whole lot like any of the Coke bottling plants I've been into, or the orange juice bottling plants I've been into. The simple operations were all the same. The only difference is they're using oil instead of other products. But at the end of the line, they have a large palletizing robot that uses a gripper to come in and grab 5 boxes at a time and palletize them. Now that gripper works most of the time really well, but over time, the clamping force of the gripper begins to wear down as the cylinder wears. And they do get to the point where if they're not careful, it will start dropping boxes prematurely. And if that happens, they run the risk of the box falling on the ground and breaking open one of the bottles inside the box. And if that's the case, now they have an oil leak that they have to clean up. They have to shut down their entire packaging line, their entire palletizing line to clean up the oil spill, replace the cylinder, and get things back up and running. So it's a significant downtime event for them if that occurs. Now, the other fun thing while we were there working on this palletizing application we ran into is they've got a very simple tape sealing device to seal the top of the boxes. This particular machine comes in, folds over the flaps, runs a piece of tape. One of the actuators on the machine closes the back flap as it enters the taping machine. If that cylinder that closes that flap doesn't actuate fast enough, it can actually cause the box to get jammed up in the tape machine. Now, there's no communications between the tape machine and the conveyor that is feeding it. And what happens is once you jam a box, you now start getting more and more boxes piling up on the conveyor belt as the conveyor belt continues to try to push more and more boxes into the tape machine until they get it fixed. So the cylinder on the tape machine is like a $20 cylinder. It takes them 5 minutes to change out. Super easy to change, super easy to fix. But depending on how long it took them to notice that there was the issue, they actually run into problems usually 2 weeks later where the drivetrain on the conveyor starts to act up because it's been damaged due to the overload of the jammed cylinder or the jammed tape machine. So they wanted to use IntelliSense to monitor that tape machine to avoid the expensive repair of the transmission on the conveyor belt. Another one is in an automotive plant. This particular plant makes large SUVs, and they use a pneumatic actuator, I think it was something like a 3-inch bore, 16-inch stroke cylinder in the middle of the system to raise and lower the vehicle body to put it position it at the proper height for the operator. Well, again, it's not that challenge. It's actually, this one is a very challenging cylinder for them to get to because it's buried in a work pit underneath the assembly line. And if they have to go in and change it, it takes a lot of time to get to it, remove it, and replace it because of its size and the shape. And we all know automotive downtime is expensive, so they really wanted to monitor that cylinder to make sure it was not going to cause them problems. And one of the things you'll notice on all of these is we're looking to monitor critical steps within the manufacturing process. IntelliSense is not designed to be installed on every cylinder in your factory. There are some limitations to the application and that kind of thing. So we really want to apply it to those critical applications within the plant. Now, this particular one is a motorcycle manufacturer, and this facility was building their engines. And they had a part washer that had a robot that would feed the cylinder heads into the part washer to get cleaned, and then it would move them on to the next step of the process. Well, the part washer had two cylinders attached to the top of it that would raise and lower the doors to the part washer. And whoever designed the robot system put in a safety check that if that door did not open within a set amount of time, that the entire cell would shut down. Now, the problem is once that cell shuts down, especially if the robot is holding a cylinder head, is you now have to go through a whole lockout tagout procedure, shut down the entire machine, go in there, take the head off the robot, replace the cylinders on the door, get that all back up and running. So it was a multi-hour downtime where they were starting to back up product in the manufacturing process. So these two cylinders were very critical to them to make sure that they were replaced regularly so that that door would open and close in a set amount of time. Fill gates. These things are a whole heck of a lot like that part washer. And there's actually another example I'll talk about that's not in here. This particular fill gate is in a chip manufacturer, and they make corn chips. And the problem with manufacturing corn chips is it's a continuous process. Once you've started the process, you really can't stop until you've filled up all of the until all the product has been bagged at the end of the manufacturing line. And they use these gate actuators on the bottom side of a vibratory conveyor to provide, to feed the bagging machines. And what would happen is over time, the gates would begin to slow down and would begin to not open and close in the right manner. And they'd start damaging product as it would fall through the gate, or they wouldn't open at all. And now you've got 5 bagging machines, and if one of these goes down, you're down to 4. And you're just putting that much extra wear and tear on your other bagging lines as you've reduced capacity because you've got a bad gate actuator. So they wanted to monitor the cylinders on those gates to make sure it was up and running. Very similar application. I don't think it's in this deck. Another place where we were monitoring gate actuators was in a gravimetric blender at a blow molding facility. Particular facility made colored bottles for laundry soap, and it was critical that that color mixture was the same every time, and it was within their customer spec. But they also didn't want to use too much of the red colorant, which is a very extensive additive. So they wanted to monitor the speed of the gate actuator to make sure, or to the gates that opened on the bottom of the blender, to make sure that it mixed the right amount. Medical. So IntelliSense is designed to be installed and left and continuously monitor an application. It's really there as a safety net. But one of the things we found with it is it also makes a great diagnostics tool, and with a little bit of flexibility can be used in a lot of other ways than being permanently installed. This particular customer made medical devices, and as a result, the FDA sign-offs on it, it was very difficult for them to make any changes to the way the machine was running or add something like IntelliSense permanently to the equipment without having to get recertified internally and possibly with the FDA. But what they were able to do was add some test ports to the system. So a couple of little 1032 quick disconnect ports, and they lined them all up on the outside of the machine, connected to the 8 cylinders inside the machine that they wanted to monitor. And they had a rolling cart that was battery powered that they would roll up once a day, plug in 8 sets of sensors, and do a intermittent check on the performance. Just tab through the 8 different screens, looking at the config screen and at the cycle data and recording that. And they were manually looking for failure modes. So it was a great little diagnostics tool for them to keep an eye on a lot of cylinders at the same time without having to permanently install multiple